Good morning, everyone. And this morning, what we are going to be discussing is basically number. Number and what's numeration, but number in different forms. Examples of number or numbers. When you're talking about examples of numbers or number, you can have 9, you can have 20, you can even have 2, you can even have 0. No, and the problem now is what we are going to be talking about. It's not really a problem, it's the challenges that we are going to see how we can tackle it, and it's going to be basically on how can we convert a number. If a number is in base 3, how can we convert this number to base 10? How can we convert it to base 10? And if a number is in base 10, basically the number is in base 10, how can we convert such number to what? To any base. Basically, how can we convert the number to what? Any base. And aside this, then we are going to learn basic operations on number bases. We can multiply numbers, we can have 1, 1, we can multiply number. A number can be what? Multiplied. A number can be subtracted, a number can be added. Therefore, we are going to learn all these particular things today. Therefore, the only thing I want you to do is just relax. Know that what we're talking about basically are numbers, and these numbers we can convert them. They can be in base and we can convert them. They can be in base and we can convert them from one base to another. Then aside that, we can add them in that base, we can divide them, we can subtract them, and basically we can even multiply them in that particular base. Therefore, it's going to be a conversion of numbers from one base to another, as I've rightly said. Then conversion from one base to another. That is conversion from one base, talking about base 10, vice versa, from one base to another. This to base 10, you are converting from one base to base 10, vice versa, or you are converting from one base to another base, and basic operation on these number bases. That's what we're going to be talking about. These basic operations here, talking about basic operation, we'll be talking about the addition, the subtraction, the multiplication of number bases. And this is what we're going to be talking about. And I want you to relax. It's not something that is very hard. It's a very simple thing. You just have to put your mind in what I want to do, and you see that it's very, very simple. Mathematics is not hard. It's fun. Take it as fun. Therefore, let's see how I'm going to go about it. And basically, before I go into it, I'm going to share some area of difficulties and common mistakes that are common mistake among the students. Therefore, students could make horrible mistakes if they just follow a recipe or a method. Therefore, you have to be very, very careful. This can especially happen when they use the shorter methods. Therefore, to convert a number from a base 10 to another base, you have to be careful when you're using a short method to convert from one base to another base. And what again can happen to students? Students should always fall back to common sense. Yes, you have to fall back to your common sense and use the method where the number is written by expanding into powers. I'm going to explain all these particular tricks for you. When students convert a number from a base 10 to another base, for example to the base 8, they use reading. They use reading the remainders upward. Yeah, it must go from up. That's what majority of them don't remember when they are doing their conversion to other base, not to base 10 this time around, but to other base. Therefore, basically, let's say, look at this particular example we have here. This particular example is converting numbers in base 10 to other base. Basically, this is in base 10, and we have to convert it to other base. When you are converting it to other base, means I have the solution 1. Let me say this particular solution 1 now. Now this particular solution 1. Then you need to understand, okay, I have the number. The number is 20. 8 is in base what 10. Then I'm to convert it to what binary. When they say binary, basically when they say binary, we're talking about 2. Automatically, the answer you are going to be getting will have only 2-digit number, which is 0 and 1. You have to watch out. If you get any number outside 0 and 1, then it means you are wrong. Then when you are converting from base 10 to what? To other base, you use a long division. I hope you still remember your long division. Now, what do we call the long division? It's a very simple thing. It's a long division. We have how many lines? Let me see. Depends on the line. If you have the number you are converting to, I'm converting it to base 2, you put 2 here. The number you are converting from base 2 must be in base 10, I put it here. Then I put what? The remainder here. I put the words remainder here. Then what happened? It means when you are using a long division, you have I'm converting it to base 2. The number that I'm converting to base 2 must be in base 10. Then I have to put my remainder. Then what will I do? I begin to divide 208 divided by 2. 2 here 1, 2 here 1, 0, put 0. Then 2 here what? 4. Remainder what? 0, no remainder. Therefore, here I will put 104. Put my remainder here. I told you that the digit number you are going to be getting is between 0 and 1. Therefore, fine, that's good. Then move again to the next one. Then I have 104. This 104, you take it to the next line. 104 divided by what? 2. How many 2 will you see in 10? 2 times 5 is what? 10. I'm going to have what? 5. Then how many 2 will you see in 4? I'm going to have 2. Remainder what? 0. Then I'm going to put here, I'll put 5, 2. Then here I'm going to put what? 0. Okay, good. I'm saying order because the digit I'm getting is within 0 and 1. Then I move to 2 again. Yes, I have to move this one again back. Okay, 52. Then divide 52 by 2. 2 in 5 is 2. Remainder what? 1. Then this particular one, this is unit 10, is 10. 10 plus 2 will give you what? 12. 12 divided by what? 2 will give you what? 6. Then that will give you remainder. So you'll be wondering, what am I doing? 2 in 5, that will give me what? 2, which is 4 remainder 1. But the 1 remainder, this unit is 10. It's 10. 10 plus 2 will give me 12. You divide 12 by 2, you have 6 remainder 0. Therefore, here I'm going to write what? 26. Then here I'm going to put what? 0. Oh, wow, it's still within. Then move to the next one. The next one will be what? 26. Then divided by what? 2 again. Let me put my 2 here. Therefore, 2 in 2, 1, 2 in 6, 3. Automatically remainder what? 0. I will have my 13 here. Then I'll put my 0 here. Then I move to the next one, which is 2. Then I have my 13 here already. Move your 13 down again, divided by 2. 2 in 13. 2 in 13 will give me what? 6. Remainder what? 1. You understand? Because 2 times 3 will give me what? 2 times 6 will give me what? 12. Therefore, in that particular case, what I'm going to have 6 here. Then I will have remainder 1. It's still within 0 and 1. Then I move to the next one. Then I have to move this one down again. 6 divided by 2. Therefore, 6 divided by 2 will give me what? 3. Remainder what? 0. Yeah. Therefore, here I'm going to have 3. Then I'm going to have what? 0. Then what again? I have to move down again. Then I'm moving down to 3. Then say 3 divided by what? 2. Let me put my 2 here. 3 divided by 2 will give me what? 1. Which is, remainder what? 1. And you can easily get it by saying 2 times 1, 2 plus what? The remainder will give you the number. 2 times 1 is 2. 2 plus 1 will give you 3, which is the remainder. Good. Therefore, I have here, what I have here is 1, remainder what? 1. Then move to what? 2. Now this will come down. You have 2 divided out. So 1 is coming down divided by 2. How many can you use 2 to 1 divided by 2? You are using 2 to divide 1. It's not possible. Can you see 2 in 1? It's not possible. Therefore, we say 0. Remainder what? 1. And it's more easier for you. 2 times 0 will give you what? 0. 0 plus 1 will give you what? 1. Therefore, here I'm going to have 0 here. I'm going to have my 1 here. I'm going to have what? My 1 here. Therefore, in this particular case, what I'm moving down is 0. You understand? Therefore, since I have my 0 here, I stop there. Then, what we're now saying is the movement will be from down to what? Up. Therefore, I'm going to have 1, 1, 0, 1, then 0, 0, 0, 0. This will give me in base 2, basically. This will give me what? In base 2. And that is what I have here. Therefore, my answer to that question will be 1, 1, 0, 1, 0, 0, 0, 0 in base 2. And one thing about this particular thing is, basically, when you convert it to base 10, we can convert it to base 10. Automatically, you are going to get this particular answer back. Therefore, when you are converting to base 10, you use what we call expansion. Yeah, you use your expansion in base 10. You use what we call expansion in base 10. And basically, when you're using expansion in base 10, you'll be using the base to multiply all the numbers. Therefore, the first one will be 1 times 2, which is the first one. This is the base, this is the number, plus, adding everything together, 1 times what? 2, plus, then 0 times what? 2, plus 1 times 2, plus 0 times 2, then plus 0 times 2, plus 0 times 2, plus 0 times 2. Therefore, the first thing I've achieved here is I've used this, I've expressed this number in base 2 to what? I've expressed in terms of what? Expansion by multiplying the base with each of these particular digit number. Now we're talking about base 10, then start adding. This should be 0, this should be 1, that will be 2. The power will begin to increase from what? From back to the front. Starting with 0, 1, 2, then move to what? 3, then move to what? 4, then move to what? 5, then move to what? 6, then move to what? 7. You understand? Therefore, in this particular case, you will need to understand that anything raised to power 0, anything multiplied by 0 is 0. That is number 1. Then anything, basically, anything raised to power 0. The trick here is anything multiplied with 0 will give you what? 0. That is number 1. Number 2, anything raised to power 0 will give you what? 1. That's then another thing you need to know is 2 raised to power 2 will give you what? 4. Then 2 raised to power 3 will give you what? 8 in power form. Then 2 raised to power 4, meaning 2 times 2 times 2, 2 times 2, 4 times 2, that will give you 16. Then you have 2 raised to power 5, automatically will give you 32. Then 2 raised to power 6 will give you 64. Then 2 raised to power 7 in that order will give you what? Basically, we give you 64 times 2, 64. Will give you what? 64 times 2. That will give you 128. you have to just know this. This is a mental math. Therefore, here I will have this will be 0 because I'm multiplying, it's multiplying everything with 0. This will give me 0 because it's multiplying everything with 0. This will give me 0 because it's multiplying everything with 0. Automatically, this will give me 0 because it's multiplying everything with 0. Now, this will not give me 0. This one will give me 0 because it's multiplying everything with 0. Therefore, what I have that is left is 1 times 2 raised to the power 7 will give me what? 128, then plus. Then 2 raised to the power 6 will give me what? 2 times what? 64 plus. Then what again? Yeah, 2 raised to the power 4 will give me 16. 1 times what? 16. Then what again? That's all. Therefore, what I have is going to be 1 times 128 will give me 128, then plus 64. Because 1 times 64 will give me 64 plus 16. And that will give me what? 12 plus 64 plus what? 16. That will give me what? 208. That will give me 208 in base what? 10. You see, what I told you is you are going to get it right. Therefore, once one thing about mathematics is what goes around comes around. You can start from the beginning to the back, from the back or to the beginning. Okay, good. Then I will do the second one. Basically, I have the solution for you here. Then the second one, basically for me to do the second one is very simple. We are converting the number from base. Basically, we are converting the number from base what? We are converting the number we are converting 208, in base 10. We are converting it to base what? 16. But when this is 16, 16 means hexa what? Decimal. Hexadecimal means 16. Decimal means 10. While hexa means what? 6. Then when you add it, we give you what? 6. While binary means what? 2. Therefore, it means since I'm converting from base 10 to base what? 16, I need to use my long method. And for the long method, you first write what you are converting into, which is 16, the base you are converting into, which is 16, the number itself, which must be in base 10, then you put the remainder. Therefore, the first thing you do is 208 divided by what? 16. And when you do this, you are going to have 13 remainder what? 0. Therefore, you will put 13 and put what? Remainder what? 0. Then you go back again, 16. Then you move this one down, 13 divided by 16. Is it actually possible if I count 13 and remove, if you count 13, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and count 16 out of this? It's not possible. Therefore, the answer will be what? Is 0, remainder what? 13. Remainder what? 13. Automatically, when you say 16 times 0 is 0 plus what? 13 will give you what? 13. Therefore, in this case, what I'm going to have is not possible. Therefore, I'll put 0. Then I'll put what? 13. And you need to know basically that 13 is D in this particular regard. Therefore, the answer, you are moving from down to up. Therefore, the answer will be D O in what? 16. And this is what we have. Therefore, basically, sometimes this is how you do your runs when you are converting from base 10 to any number. You use the long method. Now, addition and subtraction. For addition and subtraction, therefore, addition and subtraction, this is another aspect of what? number base that you need to remember. Therefore, I'll first give you some trick about addition and subtraction in number base. Therefore, I carried out exactly the same way as base 10 numbers. For example, to add, when you're adding 1 plus 0 automatically will give you 1, 0 in base 2. They are all in base 2. 1 minus 0 will give you 1, 0 minus 1 will give you 1. These are normal. 1 minus 1, just your normal, but it now comes in 1 plus 1 will give you 10. Meaning in 10 you have 2-digit number, which is 1 and 1. Therefore, and the 10 minus 1 will give you 1. Basically, the way I look at it, if in 10 you have 1 digit, you have 2-digit number, and you are removing 1 out of the digit number, automatically you will be left with 1. Another thing is, is 2, and 2 you have 0 and 1 as a digit number. Therefore, these are the tricks. Just know that when you are adding 1 plus 1 in base 2 will give you what? 10. 10 minus 1 in base 2 will give you what? 1. You'll be asking how. Very simple. I told you this one will have been 2, but you cannot have 2. You can only have 0 and 1 in this base. Therefore, we have it as 10. 2-digit number 10. Then when you have 10 minus 1, already in 10 you have 2-digit number, which is 1, 1. You move on from that 1, 1, you have 1. Although these are the tricks that you can easily use when you are doing addition or subtraction. And basically, let me see. Look at this now. We have to evaluate this particular thing in base. We have to do this in base what? In base. We have to do it in base. Therefore, what I'm going to do, we have to. They are in base 8, and you need to understand that in this, any number you are going to be dealing with must not be greater than that. What? Base. Therefore, if I have 5 and I have 6, then I have 2, 4, 3. Then I'm to add them, and you remember they are in base what? 8. Therefore, the first thing I need to do, your normal adding 6 plus 3. You first add this first column, and that will give me what? Remember, that will give me 9. Automatically, in this particular case, 9 is more than the base because it's base 8. What you do, how many 8 will you say in 9? It should be 8 divided, it should be 9 divided by the base itself, which is what? 8. 9 divided by what? The base itself, which is 8. That will give you what? 1. Then remainder what? Automatically remainder 1. And when you say 8 times 1, we give you 8. 8 plus 1, we give you 9. You understand? Therefore, in this particular case now, what are we going to do? There we are writing this 1. Basically, this one you have there is 8. It's just like saying 8 plus 1. That will give you what? 9. Automatically, what you are going to do here, you write the remainder. This is the remainder. You write the remainder here. The remainder here is 1, and you carry 1 to the next number. But the one you're carrying to the next number look like 1, but actually, let's see, you have this particular one. You take this particular one to the next number. That will be, I have 1 already. I'll say 1 plus 5, then plus what? 4. 1 plus 5 plus 4, because I've taken this number to the next number. Therefore, it will be 1 plus 5, that will give me what? 6. 6 plus 4, that will give me what? 10. So automatically I have what? 10. Then what we'll be thinking about is how many, what is the base? Is base 8. Is base 8. How many 8 will you see in 10? Basically, that will be 1. Then remainder what? 2. And you can confirm this by saying 8 times what? 1 plus what? You can say 8 times 1. The remainder is just like addition plus 2. Automatically, that will give you what? 10. What am I going to do? I'm going to write the remainder to this next number. Here I'll put what? 2 here. Basically, I'll move the next one, this one, to the next digit, which is now 1 plus 2. And that will give me what? 3. Automatically, I'm going to have 3. And 3 is not, you can say 3 divided by 8. You can't say 3 divided by 8 because 3 is not up to that number. the base number. Therefore, you leave with the answer will now become 3, 2, 1 in base. What? It is as simple. Basically, all this thing we've written here is just writing remainder, and you need to note as well that any of these number must not be greater than the base you are given. Therefore, that is addition. Then for the subtraction, if we move to the subtraction, I have 1, 0, 0, 1. Then I have 1, 1, 1. Remember, they are all in base 2 and I have minus. Basically, what you do here is 1 minus 1. I've told you 1 minus 1. In that case, it give you what? 0. What I need to do is I need to add what 0 here. From here, I borrow here. Anything you borrow is 2 because it's in base 2. This one I'm borrowing 2 because this one is in base 2 is what? 2. The out of these 2, I borrow 1 here again. Therefore, this one will have become 1, while this one will have become what? 1. For 1, I borrow here. What I borrow here, this will be 2. Any number, anything you borrow is 2. I borrow here what? 1 to this place. I'm getting to this place, I have it 2, but I want to borrow 1 out of this particular 2. If I borrow 1 from this particular 2, because I'm borrowing now, this one becomes what? 2. But this one will have reduced to what? 1. Therefore, here I have 2. 2 minus 2 will be 2. This is another way of doing it. 2 minus 1 will give me what? 1. Then basically I have 0 here. Therefore, my answer here should be 10 in base what? Should be 10 in base 2. Now let me repeat myself. Again, you need to understand that when you are borrowing, anything you are borrowing is that particular base. Therefore, if I'm borrowing 1 in base 2, it should be 2. If you are borrowing, let me say, anything you are borrowing 1 in base 2, that one will be what? 2. If you are borrowing 1 in base 3, that will be what? 3. Just note this. If you are borrowing 1 in any base. Therefore, in this particular case, now I'm trying to redo it back again. I have this, I have 1, 1, 1. Then I have minus, and you remember the base 2. Automatically, I have 1 minus 1. Automatically, no problem here, 0. But there is problem here because 0 minus 1 is not possible. You cannot remove 1 from 0. You cannot count 0 and remove 1. It's not possible. What can we do? We cannot borrow from everywhere. This was 0. So if I borrow 1 from here, this one becomes 0. Then this one becomes what? It becomes 2. Now if I borrow 1 from this one becomes 1, this one becomes 2. Anything you borrow is going to be what's in that base, because this is base 2. Therefore, out of these 2, I borrow 1. To remain 1, but what I'm borrowing is not actually 1. It's 2 because it's in base 2. Now say here I have 2 minus 1 give me what? 1. Put my 1 here. Then here I have 1 minus 1, that will give me what? 0. Put your 0 here. Then here I have 0. Put your 0 down in base 2. Therefore the answer will be what? 10 in base 2. Basically, these are the small logic that we employ when it comes to numbers of what? Base. Basically, therefore I have it as well here. Everything that I've explained there here, you can use this particular method as well. Therefore, for this procedure, what I said is pick 6 plus 3, 9. Then how many 8 will you see in 9? 1, remainder 1, write the 1, take the 1, write the remainder, take the 1 to the next one. 5 plus 4 plus that 1, 10. How many 8 will you see in 10? 1, remainder 2. Okay, good. You write the remainder, which is what? 2, take 1 to the next one. That's all. Then in this particular case, 1 minus 1 will be 0. 0 minus 1 is not possible. You borrow 1 from the next column. Here is 10. And I told you before, it's equally 10 instead of saying 2, because 2 in digits is 10. Therefore, you now say 10 minus 1 automatically. 10 minus 1 is just like you're having two digits number, then 1, 1. You have 1, then 1 minus 1. You can use this particular method as well, or use the other one that I just explained. I think that one is more easier. Anything you're borrowing in that particular way. And if you're borrowing 1 in base 2, we give you 2 in that particular order. That will make it easier for you. And you get the same answer fast. Okay?